Welcome to Stuff You Should Know, a production of iHeartRadio.
Hey, and welcome to the podcast. I'm Josh, and there's Chuck, and we're doing it together. Doing it. We're just doing it together, and this is Stuff You Should Know.
That's right. I have the rainy day blues, you guys, but we're doing it anyway.
We're doing it together.
Because a little rain shouldn't stop a indoor podcast, right?
No, but I'm with you. It's been raining too much lately, and it can get to you after a while.
Yeah, that's right. I'll persevere. The sun is shining in my head.
Oh, that's very pleasant, Chuck.
It's not true, but it's a nice thing to say.
Okay. So that reminds me of that. Remember when Pebbles and Bam Bam on Flintstones had like a brief singing career?
Oh, yeah.
Wasn't it like Let the Sunshine In? Or there was something, their hit single had to do with sunshine.
Well, I remember Let the Sunshine In, but was that the Brady Bunch or was that Pebbles and Bam Bam? You let the sunshine in, something with a grin.
I don't think it was either of them.
No.
It could have been the Brady Bunch, though. Well, at any rate, it just reminded me of Pebbles and Bam Bam, so that did my heart good, too.
All righty. So can I just briefly say what we're talking about so people don't think this is about the Flintstones?
Yeah.
Although, that'd be a fun episode, actually.
I agree. I think that is a future episode. Good idea.
All right. The shadow biosphere, which is to say this theoretical notion that perhaps if, we're constantly looking for life on other planets and it has been posited, well, what if that life exists here on Earth, but it just doesn't look at all and it's not made up of all the things that make up life as we know it here on Earth. And so we're just either looking in the wrong places or not recognizing it as something that's alive or both. And that's the shadow biosphere, this idea. It's pretty cool.
Yeah, it is pretty cool. One of the big problems that you run into when you're talking about a shadow biosphere or plotting to look for other forms of life that just don't conform to what we think of as life as we know it. The big problem is we don't really have a working definition of life, as life as we know it, like us, microbes, birds. Like there's not a real definition that covers all of them. And there is one that scientists have agreed to generally settle on. But if people who are into the shadow biosphere, which is to say usually a combination of astrobiologists and microbiologists, it's where their two fields overlap in a Venn diagram. That's where the shadow biosphere lives. They will say, like, this is wholly inadequate. Like we need to broaden the horizons or else we're never going to detect anything that's not living.
Yeah. And I tell you what, my friend, I hope one day during the life of this show, we do find life on other planets that's significant. So you will stop doing articles about it.
Well, this is okay, fair. This is a pursuit of astrobiology. But the thing that I find the most fascinating is where microbiology comes in. And they're saying, yeah, this would help us find or look for life off of Earth.
Yeah.
But it'll also help us find life on Earth. Like the idea that we share a planet with other trees of life that aren't related to us in any way, shape, or form other than we share the planet and they function in ways similar that life as we know it functions, but we're not related.
Yeah.
I think that's neat.
I think it's totally neat. And here's the other thing, too, is and this is a pretty important note, if we do find something here on life, on Earth, that is, like a shadow life form of some sort, we're probably talking about microbes, just so people don't get super excited about the idea of chuds being a real thing. That's not a real thing. We're not going to
chuds aren't real.
We're not going to go deep down enough to find any cannibalistic humanoid underground dwellers, sadly. So what we're talking about here are microbes, and what we're talking about is this idea put forth by a very smart woman named Carol Cleland from the University of Colorado, Go Buffaloes. And I think the way she came about it was like, you hear about like she came about it honestly. I think this is like one of those times because she was in Spain. She was observing some molecular biologists They were looking for soil microbes and microorganisms, looking through these samples. And she was like, hey. And they went, see? And she said, how do you know, like, that you found something new, like a new microbe? And they said, well, and I'm not going to say this in Spanish because I didn't translate it all. I just know what yes is.
See.
But they they said, well, what we do is we look until we find something that looks like it might hold some promise. Then we, we've looked at it under a microscope. Then we put it in a petri dish and just grow the heck out of it, and then isolate its DNA, and then look at the genome and see, like, hey, what does this look like? And then she went, oh, that's kind of cool. But I have another question. It's kind of like Tom Hanks in Big. Like,
They're
I
like,
don't get
you're
it.
still here?
She said, well, what if it's not related to life on Earth? Like, how would you even know how to recognize something as being alive? And they all shrugged, and she wrote a book about it.
Oh, see, I imagine them all freezing, and one of them just drops the petri dish without, like they can't believe what they've just heard. They're stunned.
Yeah, and COVID was in that petri dish.
So Carol Cleland makes a really excellent point, and like you said, this kicked off the idea of shadow biospheres, and in fact, she coined that term. But what she's saying is that our process of looking for life would just walk right past anything that doesn't conform to our understanding of life, but that still is living in a certain definition of things.
Nailed it.
Yeah. So just to kind of step back for a second, there's a consensus among scientists that life conforms to a few rules. This is the generally agreed upon definition of life. It's carbon-based.
Check.
Anything else is non-living. You know, you look at a piece of quartz, it's from silicon, I think, not living. Great example. Thanks, Josh. Okay. It's programmed by DNA and RNA, right? So it has transcription of its genetic code, and that is just, it does not live without that. Those things are built by amino acids and proteins. Those are the basic building blocks of the organism. It's self-replicating, very important. And then it also evolves according to Darwinian principles, which is to say that the best properties and traits are selected for over time. So if you put all those things together, you have a pretty good idea about life. But again, this is a really narrow definition. And if you really kind of look at it, you're like, there's a lot of room for other things to function in a manner that's living, that doesn't necessarily use DNA or RNA, that doesn't use amino acids, or at the very least, the amino acids that we use. And it might not even be carbon-based. Like, maybe we can broaden this a little bit, and that's the pursuit of shadow biosphere.
Yeah, and Carol Cleland was right on the money. Said she wrote a book. It's really a paper, but, she could bind it like a book and probably sell it in a store.
Sure.
But it was called The Possibility of Alternative Microbial Life on Earth. We're also going to, talk a little bit about looking on other planets, because we've talked a lot about that. And suffice to say, when we're looking for life on other planets, we're always looking for like an Earth-like place where something like life as we know it could exist, kind of in the same way. But she was like, this stuff might be right under our noses, everybody. Right. And here's a paper about it. And I think it was a pretty smart paper. There was should we talk about the central dogma, I guess? Yeah,
I think we need to.
Yeah. So, you went over what life on Earth contained, but the central dogma is a little more specific. It was first proposed by Francis Crick in the 1950s. That is that DNA, the nucleic acid that we know and love, has instructions for building all the proteins that are required for something to be alive. You also have RNA, which copies those instructions to take them to the ribosomes, which also exist, because that reads that RNA and assembles everything, all those amino acids, to make each protein, and bada bing, bada boom, you have life.
Right. And so you take that process and you end up with what's called the origin of life, the genesis of life here on Earth. And
Genesis.
We've talked about this. That's the scientific way of saying it.
Well, okay. Good to put on my lab coat.
We've talked about this before multiple times. Remember, we did an episode on panspermia.
Oh, yeah.
We've done a bunch of episodes that I think this primordial soup came up. And that's the whole idea, that either in some shallow tidal pool or, some warm part of the ocean or some body of water, there was a bunch of those basic building blocks of life, amino acids, proteins, floating around, and that somehow a self-replicating process got kickstarted. And the self-replicating process is considered what's called a privileged function. This idea that this mechanism for creating life was present at the outset and is still around today. So we self-replicate. A couple others were metabolism. That's another suggestion for the privileged function that kickstarted life. Or then compartmentalization, like having something to hold all of these processes in, like a bag of guts, basically. So one of those, they say, is what was responsible for kickstarting this process of life, and that somehow, some way, a bunch of chemical reactions started a chain reaction that became self-sustaining, that eventually turned into increasingly complex processes, organelles, and eventually living organisms. That's how life developed. That's the idea behind the primordial soup that the central dogma is based on.
That's right. But in Cleland's paper, she was like, well, hold on a second. That's great. What a story. We love it. We all believe it. But what if this happened like more than one time? What if it happened multiple times right here on Earth?
Right.
There were just different conditions in different places. Different chemicals came together. And what if that happened and these are the shadow microbes? And what if this stuff is still there? And the reason that we haven't found it is because we're looking for life that we understand as being alive.
Right.
And the ramifications that would have, not only to find stuff like that here on Earth, but, this idea that when we go out and look in outer space for life on other planets, again, we're looking for Earth-like, atmospheres and Earth-like conditions. She was like, well, what if we're looking on the entirely wrong planets? There could be stuff that's alive because we're just not looking in the right places because we have such a narrow definition.
Yeah, and we definitely have found increasingly extremophile organisms. Like for a long time, we thought that organisms couldn't survive past 120 something degrees Fahrenheit. Then we found some extremophiles that can survive around hydrothermal vents that are as hot as 212 degrees Fahrenheit. We're like, okay, that's pretty awesome. But it's still life as we know it. Like they're crazy in their adaptation, but they still function according to the properties of life as we know it. What Carol Cleland and others are saying is like, okay, we'll keep looking in even more extreme environments. And eventually you may find something that has had to adapt to such an extreme environment. It uses different processes or different raw materials that life as we know it could not possibly use. And there you have your first shadow bioorganism.
I think we should take a great rest here. A long rest.
We'll be back, everybody, after this rest.
And lo, the podcasters rested.
Lo.
And then on day 2, they got on with the show. We should mention, by the way, we did a pretty good episode on extremophiles.
Yeah.
A while back. So just if you haven't heard it, you should just look up on the search engine of your choice, extremophile stuff you should know. Pretty neat.
Yeah.
But back to shadow biosphere. We mentioned the fact that, Carol Cleland's beating that drum saying, what if it's not something that we recognize because we just don't recognize it as life as we know it? And then she started digging in and she was like, here's the thing. DNA and RNA aren't the only building blocks of life in theory. They are made of base pairs of nucleic acids. For DNA, it's adenine, cyanine, guanine, and thymine. For RNA, it's thymine that is swapped out for uracil, but the other three are the same. but there are more nucleic. I believe there are 6 more nucleic acids that exist in nature. So, why are we not even considering the fact that those could be a part of life in a way that we don't fully understand?
Right. And first, Uracil sounds like an over-the-counter urinary tract infection treatment.
Totally
And
does.
secondly, I could not for the life of me, and I really looked, find what the other 6 nucleic acids are. I can't find it, Chuck. But in that search, I did come across something called the Hachimoji DNA, which is those 4, AT, which is always together, and GC, which are always together to form those base pair nucleotides that eventually build up into DNA. And they added P, Z, B, and S. And
that's them, right?
That's 4. So there's still 2 missing.
Yeah. Oh, okay.
But the really interesting thing that they found is that if you if you rearrange, say, the original 4 base pairs, or you add these other brand new 4 base pairs and run them through a ribosome, the ribosome, if you arrange it correctly and they're made of nucleic acids, the ribosome will be like, okay, I'm transcribing this. So it's entirely possible. They proved that it's possible that life could have evolved separately from us by using different amino acids, but similar mechanisms. So maybe we are, or could be in this sense, distantly related to them, like maybe in the primordial soup, but it branched off so early that for all intents and purposes, it's non-living life as far as our definition of life goes.
Yeah. Well, nice job finding 4 of those 6 letters at least.
Thanks.
Let's just call the other 2 FU.
Science.
Yeah. So so that's how DNA and RNA could be, different as we know it. The same thing is true for amino acids. All the proteins are built from the same combination of 20 amino acids because when Earth formed, those were the 20 amino acids that, in a Darwinian sense, were most successful making proteins that survived when life emerged. There are 500, we're not going to name them, 500 other amino acids, or more than 500 amino acids on Earth.
Exclamation point.
Yeah, totally. So it's just the fact that Earth started when it did, that those particular 20 amino acids were the ones that were good at doing what needed to be done to make things that survived here. But it could have been, at a different time, it could have been any other combination of amino acids, and they're still out there.
Exactly. So a lot of scientists are like, well, that just goes to show you that life as we know it is the only kind of life. If we're using the same 20 amino acids and there's all these others out there, these are the ones that got selected for. These are the ones that worked in the primordial soup. And Carol Cleland steps forward again with her index finger raised and says, okay, I can see where you're coming from. But again, as I said before, if life emerged in other places, in other situations, under other conditions in the primordial soup, it's entirely possible that completely different combinations of the other kinds of amino acids were the most usable and were selected for that. And again, this is how the Shadows Biosphere could have started. And another Petri dish got dropped. And these guys are starting to second guess, undermining Carol Cleland, or even attempting to, because she just keeps facing them over and over again.
Yeah. And they're like, well, how would that have happened? Or how could that happen? She said, I don't know. How about a meteor, sucker?
Sure.
Because meteorites have fallen to the Earth, and asteroids that basically plant stuff on Earth that come from another place. There have been meteorites that have fallen that are carrying up to 80 other amino acids. And her whole theory is that, like, what if this has happened, and maybe it's happened repeatedly, and again, we just don't know about it because we're not looking correctly.
Right. So, the panspermia episode, that was the basis of it, that Earth got seeded with the necessary ingredients for life from space, right?
That's right.
So there's another peculiar aspect of life as we know it that doesn't really make sense to us. And I don't fully get how it would tie into the shadow biosphere. So if you do, let me know. But the best I can understand is that because we don't know it, and because it's it just seems like a random arbitrary development in life as we know it, that it suggests things could go the other way, and maybe they have elsewhere on Earth. Is that how you read it too?
Yeah, I think so.
Okay.
Just like an example of like, see, this can happen.
Right. Okay, good. That's what I'm taking it as too. And we're talking about chirality. And chiralness is handedness in Greek. You're either right-handed or you're left-handed. Or you could be ambidextrous, but that's neither here nor there when we're talking about cellular biology or molecular science, which is what this pertains to. And if you make a bunch of sugars or a bunch of amino acids in the lab, some are going to be left-handed and some are going to be right-handed. But as far as life on Earth is concerned, only left-handed amino acids and only right-handed sugars can be useful as the building blocks of life. So there's right-handed amino acids and left-handed sugars, but they are completely useless to us because all life on Earth only uses left-handed amino acids and only uses right-handed sugars, and we just don't know why.
Yeah, and if this sounds like, all right, guys, what are you talking about here with these hands? It's not hands. It's the direction that their atoms are oriented.
Yeah.
They talk about it in terms of handedness, I think, just as I hate to say it, as a shorthand. So dumb humans like us can understand what they're talking about at least halfway.
Right. And so because there's left-handed and right-handed amino acids, they are mirror images of one another. They're constructed the exact same way. They're constructed with the exact same components to make up these molecules, but they are mirror images. So if you overlay them, they're not twins, mirror images. So in exactly the same way, if you hold your hands out in front of you, palms down, so the top's up, and you just kind of hold one over the other, they're not twins. They're mirror images of one another. And that's exactly true with amino acids and sugars. They each have a mirror image. And again, only one kind is useful to life. The other ones just get spit out. So what if, again, under different conditions at some point in the past, there were organisms that learned to use the other kind, left-handed sugars and right-handed amino acids? That would certainly qualify as a shadow biosphere bioorganism.
Yeah, and we have synthesized these in labs. But what's the deal? What I don't understand, if they were able to synthesize it, that means that it did already exist, but it just isn't anything that was alive?
Yeah, I don't know exactly what they did. They built a cell that uses right-handed sugars.
Amino acids.
Yeah. And they I don't know if it was living or not. I don't think it was living, or else they would be like, we created artificial life here. I don't think anyone's ever done that. I think they just created the structure of it. Like if there was something like a cell that used that kind of stuff, this is what it would be structured as. And the whole reason they built it was to try to attract things like chiral viruses that function using the opposite stuff that we use for life. It was a honey trap is the way that they put it.
Like they take it out to a club and set it on a bar table, and they're like, hello, everybody.
Exactly.
Here.
Right. So nothing came along and took the bait, but that doesn't mean it's not there. The better argument against things like that living, if you ask me, that I ran across, is that if you did have something like that could consume other things, it would have no natural predators. It would not be able to be infected by any of the known viruses we have. It would be unstoppable, and it would replicate in such an unchecked manner that it would apocalyptically destroy the food web based on whatever, one microbe that it feasted on. And because that's not happened, there's a pretty good chance that there's no such thing as that.
Yeah. I guess now we can talk a little bit about the last universal common ancestor, or the LUCA, which is the idea that all life on Earth can be traced back to this very first functioning cell that started the whole party. If we believe in something like the shadow biosphere, there can still be a last universal common ancestor, I think, in terms of what created our life. But we have to consider the fact that there were multiple genesis that happened at a certain point. And, maybe they just didn't evolve because, part of that opening four things that we talked about was that things evolved in a sort of the Darwinian sense that we recognize. Right. But the idea of the shadows biosphere is maybe these things did occur at various sort of calm periods on Earth where there weren't, ice ages, or it wasn't being bombarded by asteroids, and that they're still there. They just never evolved. They're just sort of trapped.
Yeah, that's one example. There's another explanation that they might be in places we haven't explored yet. So
Yeah.
like there could be, life on the surface of Earth, and then we find microbes all the way down to some, level, and it gets too hot for them, and then it's a dead zone. Well, maybe beyond the dead zone, there's these, shadow biosphere organisms. And then another argument I saw against the idea. So a lot of scientists are like, sure, it's entirely possible there were different origins of life, but the other ones sputtered out. Only ours continued on. That's not a very controversial idea. What's controversial is that it didn't sputter out, that they just evolved and we share Earth with them, right? But a lot of the arguments against that state that, okay, well, maybe it did make it beyond the sputtering stage, and it was, we shared the primordial soup with it, but it got absorbed into us, and now it's a part of us, but, not really anymore. And that misses the point, because what they're talking about is lateral gene transfer, where, like, say, one cell just takes over another cell, and they share DNA from that point on. That's totally missing the point. Like, that would not be a shadow organism. It'd be an early additional ancestor to us. This is stuff that we couldn't possibly have, mixed with to become us, or else it wouldn't be a shadow bioorganism. It would just be another component that created life as we know it.
That's right. And lateral gene transfer was totally an a cappella singing group from the 70s, a gospel group.
Oh,
led by a guy named Gene.
Nice.
Yeah.
Wow.
I've got the record. It's not even a joke.
Are you kidding? You're not kidding?
Ha! I got you.
Wow, you did get me. That was good.
Finally.
Well, the
Sweet
70s were
revenge.
pretty wacky, so.
Oh, goodness. It is a meal best served cold.
Do you want to take a break and savor that for a little while?
Yeah, sure. Let's go ahead and take a break. I'm going to take another nap and dream about getting Josh, and then we'll be right back.
All right, Chuck. So we said that, or I should say you said at the outset that nobody's looking for, some silicon werewolf or something.
Right. Oh, man.
So,
That'd be great.
So instead, we're looking for microbes. And the reason that everybody agrees if there is a shadow biosphere, it's microbial life, is a couple of reasons. One, we could look at a microbe and look right past it. They don't have faces, they don't have tails, they don't have hair, they don't really have any features that would really stand out just visually. We have to really examine them to find the differences that we would be looking for. And then on top of that, we've only cultured and described less than 1% of all of the estimated species of microbes on Earth, right? So we have very little understanding in the big picture of the microbial life we share Earth with. So it's entirely possible. We just haven't stumbled upon one yet, but that doesn't mean it's not there in that other 99% of the kinds of microbes on Earth with us right now.
Yeah, for sure. And, we've kind of walked around this very plain statement, but the plain statement is look where we think, or look where we so far think that nothing here can live, because that might be a great place to start. If we're like, oh, nothing can live in the Dead Sea microorganisms because it's so full of saline that we just know nothing could live. Like, well, maybe start there. Or you mentioned earlier the fact that things we didn't think anything could sustain life greater than like 122 degrees Fahrenheit, but then we discovered colonies of bacteria that could. And we're like, well, that's evidence right there that maybe we should look in like really, really hot places, really, really cold places, really acidic places, really base places. Anything on the list that says human life can't exist there, maybe start looking there.
What's crazy is when we have looked there, we keep finding stuff that can exist, like life that is doing just fine there, that just should not be there. The best example I found are types of, I think, slime mold maybe, or algae that it lives in abandoned uranium mines. So this place is so crazy radioactive, no life should be able to survive there. And yet they think these things are actually taking that radiation and using it as chemical energy. And then there's also a kind of single cellular life that they found growing in one of the abandoned Chernobyl reactors. Again, should not be there because of the radioactivity. But these things still conform to the basic principles of life as we know it. The point is, though, is you just keep thinking in more and more extremes, and maybe we'll find it. Like the upper atmosphere is the one that's suggested. Because no life's supposed to be able to live up there because of the cosmic rays and the temperature and all that stuff. It's just not a pleasant place to live, from what I understand. And then other people are like, okay, if we keep looking and in these more extreme environments and we're just finding life as we know it, maybe we should look around and see if we find anything weird in places like right under our very noses. And one of the big ones that has been touted as desert varnish. And this one, from what I can tell, is still, the jury's out whether it's a shadow bioorganism.
Yeah, or not.
Or not.
You're hanging out there like a Chad. So yeah, if you've ever been out to the desert in the United States, if you've ever driven around like Utah or Arizona, maybe even Colorado, maybe New Mexico, you might have been driving along and seen like a very sheer sort of cliff face. And within that cliff face, you might be like, oh, that's this weird sort of shiny, dark area of it. They're always really arid environments. Indigenous peoples used to create petroglyphs. So instead of like, writing on something, they would scrape away that varnish to make their art for the original lighter colored earth underneath it. But I've seen these things in person. I've driven by it, and I didn't know what it was. I just figured it was dark rock or something.
Right.
But it's called desert varnish, and scientists have been fascinated for a long, long time. One reason is because it grows about the pace of a width of a human hair every millennium. And because that happens so slowly, they were like, well, this is just a geological process that's going on. Maybe the sun hitting it. Some sort of chemical reaction takes place. But they found that it's actually a living thing, right?
They don't know. There's no geochemical process that accounts for it. There's no biological process that accounts for it. They just don't know. It's largely manganese in nature, but the problem is that it's not drawing manganese out of the rock. Like a lot of these rocks don't have any manganese or have such trace amounts that it certainly wouldn't account for this desert varnish. So they just don't know how this stuff is growing or what it is. But it's probably the greatest contender right now for a shadow organism, from what I can tell. Like they're like, well, then it must be a geochemical process we just don't understand. And it's like, maybe what you're calling geochemical is actually life in a different manner.
Yeah, I guess there's just the theory that it's alive, that it's biochemical.
Yeah. There was also one that was like, we found it, everybody. We found the shadow organism, and it went downhill from there back in 2010.
Yeah, that was GFAG-1. That is a bacterium that was found in Mono Lake, California. And they were like, well, this bacterium is really weird because it's not sort of playing by the rules that we understand. Because if you're going to be a living thing, to make DNA and RNA, you need phosphorus, and it doesn't look like this thing is using phosphorus. It looks like it's using arsenic, which would be a huge, huge find. And so they thought, GFAJ-1, you're the dude. And everyone was really hot on this idea. And then they did follow-up experiments and very sadly found out that it used very, very, very small amounts of phosphorus. And it just wasn't instantly evident. So they were like, all right, just another extremophile that's that we understand.
Yeah, now we know. And
Still cool.
That's another benefit of it. Like we're finding stuff because we're out looking for shadow life. We're finding other life still too. So it's not like they're like, oh, another extremophile. It's never been seen in the history of humanity.
Just junk it.
That's an interesting way that you pronounce that. I've been in my head pronouncing it Gafage Uno. So okay,
Oh.
let's move on. Let's move on to life with a Y, Chuck, because I think that's a good next place to start.
Yeah, there's a guy. Well, here's the idea is that like, hey, maybe we should just accept the idea that LIFE isn't all we think it is. And maybe it's broader than that. And maybe we just need another definition, LYFE. And I think that was put forward by an astrobiologist named Stuart Bartlett, not Bartlett, just Bartlett.
Sure.
And he said, well, maybe that is the LYFE definition is just any system, and this is a quote, any system that fulfills all four processes of the living state, namely dissipation, catalysis,
Either one. Catalysis.
homeostasis, and learning.
Yeah. So just to get into it real quick, dissipation means that it dissipates energy or something like waste byproducts like heat. That's a big one, or else it'll overheat and die, or it will never poop out its food and will die from that. It's just a really easily overlooked component of an organism that can keep going. Also, it needs to be able to make more copies of itself. That's the autocatalysis. Sure. That's important because what it's doing is it's creating a process that creates another version of itself and also a product that triggers that process over again. So it can just keep going. It also has to be able to maintain homeostasis. So it can't just go totally haywire anytime, somebody nearby coughs. And then lastly, it's got to be able to record information about the environment. Like this is how you keep from going haywire when somebody coughs. And it can be encoded in some way, shape, or form so it can be passed on to the replicants of itself.
Yeah.
That's life with a Y. And I think that's exactly the kind of broadened definition that we need. And the other thing about life with a Y, that includes life with an I, like life as we know it. And just saying life with an I is so much less clunky than life as we know it. And it falls under a larger umbrella. So it's a broader definition that includes life as we know it, but also potentially includes members of the shadow biosphere as well.
Yeah. And what this potentially means is if there is life with a Y here or elsewhere, that means that kind of anything is possible. It doesn't mean that, hey, there's intelligent life out there, but it doesn't mean there's not. I mean, it would certainly kind of inch us toward that idea in a very real way if we found that there is a different kind of life we just never understood before here or elsewhere. There's a astrophysicist named Paul Davies, really smart guy, obviously, who has done a lot of scholarship work about intelligent life elsewhere. And he talks about timing a lot. Like, Earth happened the way it did. And this is kind of like what we touched on earlier. Earth happened the way it did because of the timing of it all. We've been around for about 4.5 billion years, and we won't be around in about 1 billion years. Like the Earth will be scorched, basically, by the sun. And it was just sort of cosmic luck that everything evolved when it did, as it did, because there's a kind of a short window in the grand scheme of things between when something starts happening and being able to get to the point where you have like intelligent life like human beings and the planet being scorched or being blasted away by a large rock. Yeah.
So Paul Davies' argument kind of suggests that life is probably pretty rare, if not singular. Like we do know that life emerged once in the entire universe that led to us and all life as we know it. But that's it. We don't know that life emerged anywhere else, any other time, including on Earth. And that's one of the things that would make detecting a shadow biosphere so amazing. Is it would essentially immediately say the universe is teeming with life. If life developed two different ways on the same planet, that strongly suggests that not only is there life elsewhere in the universe, but that biology is as immutable a cosmic or universal law as physics or chemistry, right? That if you have even just a few components put together, that gives rise to life, biology is going to take over and life will arise. That's ultimately the most exciting thing that gets scientists jazzed about looking for the shadow biosphere, is what the implications it will have about us sharing life elsewhere in the universe.
Yeah, totally.
Pretty cool stuff, huh?
Yeah,
I like it, Chuck. I'm glad that we did this. Thanks for doing it with me.
it was fun. We got through it.
Yeah, we did. Well, since we got through it, everybody, that means it's time for listener mail.
I'm going to just read this one from Joel because it's kind of just a fun little ditty. Hey guys, well, I guess it's not a ditty, it's a story. First off, I want to say thanks for all the work you do to create an enjoyable and informative listening experience. I've been a casual listener since 2018, and your show has positively redirected the course of my day or staved off boredom through long winter nights because I live on Salt Spring Island, BC, off the coast of Vancouver Island, and work at a golf course there. Today I was mowing the fairways on a wet and dreary morning. I put on the Manson Murders podcast and relaxed into my work. Partway through, Dennis Wilson came into the story, and Chuck mentioned his solo album. I think it's called Pacific Ocean Blue, maybe?
I don't know.
I think so. Great record. Feeling a little low, I decided to pause the podcast and listen to the full album. I listened to all the songs as I continued my mow lines. Truly a wonderfully enjoyable album. Thank you for that excursion into the music. Once the album finished, I listened to the mower for a few minutes and then resumed the podcast. And the first words I hear are Chuck saying, "Eventually, they leave Dennis Wilson's house." And I chuckled as I genuinely felt I had just been in his house myself.
Neat.
Anyway, short little story for me. Thank you for the years of entertainment. Keep up the great work. That is from Joel. And Joel sent a picture of that fairway mowed while listening to Pacific Ocean Blue. And Joel, it is a beautiful golf course, and I would love to play it one day.
Oh, very nice. Yeah, you're a golfer. I forget that sometimes.
I am. I'm not very good, but I enjoy putting the phone away for 5 hours and walking around with my buddies in the sunshine.
Very nice. Well, thanks a lot, Joel. Much appreciated. We love stories like that. And if you want to be like Joel, send us an email. Send it off to stuffpodcast@iheartradio.com.
Stuff You Should Know is a production of iHeartRadio. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.